Well, the Roskamp Institute over the last 3 years has developed this relationship with Southeast High School TSA, and the work and the projects these fine young gentlemen and other team members have done has exemplified our mission to bring science to the community and show that science is a valid part of everyday life. And it's an opportunity for these guys to come in and see cutting edge technology and work side by side with world quality scientists. And we hope that these guys, we can influence them and they can come into a scientific career. These guys are our future and we very much want them to maintain their interest in science. And hopefully in the next few weeks we will actually be offering internships for some of these TSA students at the Roskamp Institute. For this year's project with spider silk, I automatically, when they said, well, we're doing a project on spider silk and genetic engineering, and I automatically thought, well, Dr. Ganyare Gazella, who heads up our genetics lab, she's an expert in transfection and genomics, and it's a perfect fit. Her expertise in the field will just enhance the project and be an excellent resource for the team.
What was fantastic about when we got here, the first thing is we pulled out a flipboard and Dr. A. Gazella just started drawing things about the actual processes. So it was, we jumped right into the science, and that was fantastic because we got to learn so much from somebody who's worked for so long in the field. Well,
the Roskamp Institute's a fairly unique organisation. We're a non-profit. Our primary mission is targeted drug discovery. Our secondary mission is education. We have the only PhD program in the Manatee, Sarasota County area, and it's our intention to try and capture local talent like the TSA team members, enhance their interest in science, and try and provide conduits for education, and hopefully by getting the students more involved and interested in science and more qualified, that will in fact attract more biotechnology firms to the area, and therefore at the same time, by increasing our education levels, actually improve the economy of Sarasota and Manatee counties. The staff actually very much enjoy working with young people. We before the TSA project started, we actually were taking interns from State College of Florida, New College, USF, and actually we're inundated every year from students all over the country, and actually international students who want to come and volunteer at the Roskamp Institute, because we have cutting edge technology that they wouldn't have access to even at universities. And the staff actually very much enjoy teaching willing, eager students all about what we're doing and what they could potentially do as well. And the other thing is, it's great fun. That's the most important thing. It is fun. And if you can do something and teach someone and enjoy it, it's a win-win situation. I hope that this becomes almost institutionalized. I very much hope that with the help of Manatee School Board that we can really build on this. And as I said before, the internship program is the next step, and I really would like to see the science curriculum take off from the K through 12 all the way through college and then onto graduate school level at within Manatee County. We've got the high quality, talented students here. Let's keep them local.
For the 2011 TSA State Championship, the Southeast High School Biotechnology team decided to work on the biotechnology project. We decided to focus on finding a new biomaterial, in this case spider silk, and using biotechnology processes to create it in large quantities. Now, spider silk is a very unique biomaterial because it has very high strengths and very high elasticities. However, many problems are also associated with it. For instance, spiders are incredibly cannibalistic and very territorial, which makes storing them incredibly hard. However, Randy Lewis, a professor of microbiology at the University of Wyoming, has a new and daring approach to this problem in biotechnology with spider silk. He has decided to transplant the genes for spider silk proteins from spiders into goats to produce them in large enough quantities for human manufacturing uses. First, of course, we contacted the Roskamp Institute to guide us through this entire process. They were a great help for us. They sat down, they explained the entire process to us. They gave us basically a lesson of everything involved in the process of the actual biology. Next, we contacted Dr. Randy Lewis himself in Wyoming, and we sat down for a 1.5 hour Skype interview on Skype. And he told us everything about his research. He basically opened himself up to us and told us whatever we needed, we could get from him. And next, we took to the internet, to the library, to our textbooks, and learned everything we could possibly learn about genetics, biotechnology, everything. And then we all formulated it and synthesized the project that we have now. We're definitely going to be working very hard for the next few weeks. We'll definitely be upgrading our board and reviewing the processes. We'll be in touch with Dr. Randy Lewis again to edit our manuscript and to get everything working properly. I think we're also going to be doing a little more research into the applications and uses and making it more applicable to society and making it more user-friendly to a lay person, so to speak, who isn't knowledgeable in biology terms.
So one of the few things after we contacted Roskamp is, as my colleague mentioned, we started to learn a little bit more about the actual biology behind that. Now, the biology behind it is quite high level, so we had to go above and beyond the scope of our actual curriculum in school. And Roskamp was instrumental in helping us figure stuff like that out and working with us on our level of knowledge to figure out something that's quite a bit higher up. Of course, contacting Dr. Randy Lewis helped along the same vein, except he talked about more of the specialties that he did. A few of the difficulties, of course, were the fact that we had to work with professionals and being students. We had to sort of work out on that level. And it was something I think that was a very enlightening experience because working with people who are actually doing something that you're interested in helps you learn more about it in a different way than reading about it. So being a project in genetic engineering, I think all of us had the opportunity to work on something that was actually applicable. And that makes a huge difference than something that's usually when we work on a conceptual basis. Working with a research project that has applications in real life and puts together sort of science, technology, and engineering in one project gives all of us a sort of a facet to click into in the project, and it helps us develop and get a more comprehensive understanding of what goes into a sort of real research project that students probably don't get to work with very often. When you're talking with somebody who actually works in the field, it's significantly different from talking to a teacher or somebody who works on a more fundamental level with that. And I think it was extremely helpful to talk to the
problem that we encountered with the spider silk project was actually the abundancy of silk. Since spiders are known to be cannibalistic and territorialistic, it means they can't be kept in one confined space, because they'll eat each other, and which is really bad. So basically, we came up with a problem. Instead of having a lot of spiders together to make to get enough spider silk to be used in surgery and everything, we actually splice spider DNA, major spideroin 1 and 2 genes, into a goat cell and transfer that into a goat embryo, which we can then implant into a goat so it can give birth. And the goat will have the ability to produce the protein for the silk inside its milk. The goat's milk is gathered up into a vat where it is then ethyl alcohol solution is added into that into the spider silk milk, where this actually solidifies it and makes it into so it gets easier to gather the protein. It's fed through a vertical extraction column where the thread is produced and extracted from the protein extracted. And it's basically wound up on a spool to be used in genetic processes.
How we came together for this project is there's a club called TSA, which is Technology Student Association, and what it involves separate events that people combine in and compete in competition at the state and national level. For this project, we designated who would do certain responsibilities for the project. Max would be the head researcher and research all about the topic. Jacek would help do the notebook and help with construction. Same with Kevin, which would also do most of the notebook. I and Scott would do the construction of the display board to help visually enhance the topic about spider silk. For this project, I learned that professionalism is a big part of life. Also, I learned many things about biology which I wouldn't have learned before, and I also appreciate all the help that Roskamp and Dr. Randy Lewis has given us.
Well, I'd like to take some time to talk to one of the most instrumental people in getting this entire process, this project, off the ground. Here at Roskamp, Dr. Gania Eitgazela. She was very instrumental in this entire process, and she was sort of our go-to gal, in a sense. Whenever we had a question, she was the first person that we talked to, and she gave us incredible advice and taught us things that we haven't even learned at school yet, and that I doubt I'll be learning until about 2 or 3 years into college. And she really helped us so much, and I don't think that we would be here as state champions without her. So tell me, Dr. Gania Eitgazela, what was the first thing that you thought of when we all walked in the door with this crazy idea?
Well, it wasn't that crazy idea, but your idea was already very well matured for, high school student when you walked in. You already knew what you wanted. Even though I have some suggestion, I think you already have set your mind into using a goat as a model for producing the Kevlar. I remember talking about using E. coli, more simplified, but you have your mind already set. So I think I knew from then it will be an easy task for me because you already have done the work beforehand.
And when we went to the state competition, when we sent you our final draft, what did you think of that?
Well, I was expecting it kind of to have more visual in the draft. I kind of went through it. There was some information I probably asked you to address. I was hoping to see it before, but it didn't happen. I guess it was the time constraint, but I was really, really pleased with the results.
So tell us just a few of the things that you personally did to help us. I mean, I know there were a number of them, but just detail a few of them.
Well, I think my help was really in terms of genetic engineering. I'm a geneticist. I have a geneticist background, so I kind of try to help you understand what goes into genetically engineer in a species and what the different method you can use, and then you made your choice which method you use. I think my input was more into the technicality of the aspect of your project.
And how difficult do you think it was to sort of convey the things that you were trying to tell us?
I don't think it was really difficult because, as I said earlier, you have done your homework prior to coming here to Roskamp Institute. Probably there's some technique that were hard to convey, but that's just because, your science background probably is not yet at that level. But I think you guys were really, really easy to help, and you took everything in and learned, and in that process I also learned from you. I am a geneticist, that's right, but I didn't know much about Kevlar, so I had to push myself to learn about it as well. So it was a learning experience for me as well.
On behalf of our entire Southeast High School biotechnology team, we want to send a big shout out and a great thank you to the Roskamp Institute for helping us so much on this year's project. We couldn't have done it without you, and we hope to be back for many years to come.
Our visit today is a result of 3 years of very serious collaboration with Roskamp Institute. And what began with a phone call from Southeast High School, I was calling and I said, I have these students that have a agriculture and biotechnology project. We're interested in working on something and we think maybe you could help us. And the next thing you knew, we're 3 championships later. The first thing that we did was Alzheimer's,
Correct.
if I'm not
Yeah,
mistaken. We won first place at the state and I believe national at that level. And then the second research project last year was about
Diabetes.
same thing. We also tie that into scientific visualization, which is a video animation project. So we got 2 for 1 on that one.
Oh, yeah.
And then this year we came back with a spider silk project. So for our students in Manatee County, what this means is that the sense of excitement, and it really ignites their ability to see how things can work in real life. And very rarely do you have a business partnership like this that becomes a 3-year and hopefully a forever partnership. So Manatee County School District, Southeast High School, we're all very happy that we have this great relationship with Roskamp Institute.
And from the Institute's point of view, we were, when I first got the phone call, I thought, okay, high school kids, yeah, we can do an easy project with them. And everyone at the Institute was stunned by the quality of the students coming out of Southeast TSA. And actually on our website, still today, if you look at the Roskamp Institute website, on the front page, we still got a video there that the Southeast High School TSA students produced. And it was a national championship winner, but it is incredible quality. It is almost like a professional production. We were stunned. It's fun to do. It's a fun thing to do. And the unsung heroes of the TSA organisation actually are people who are in the background. The staff that dedicate their time to help these kids and develop the talent that's there. There's Bob Burwell that no one ever sees. He never ventures out from the school, but he's there constantly working away like a beaver. Margi herself, Irene, there's a whole bunch of support staff and parents that are dedicated to making these opportunities happen for their kids.
It's a great win-win, and I know on behalf of the superintendent and everyone in our whole science curriculum department, certainly Southeast High School, is so grateful that we have not only helped put Roskamp more on the map than it already has been, but I think we've also identified around the country where the students have collaborated, mentioning Roskamp with these projects, talking about new ways to find science and make it work for the betterment of our society. So it couldn't be any better.
I'd just like to take this opportunity to emphasise the positive things that a business or organisation can have by reaching out and getting involved with these programs. I highly recommend that other businesses in the area open their doors to programs like this. Think about taking interns, get the students used to the workplace, work at a different level. This is professional level stuff. And I think if we can do that, it'll just make our community more vibrant and stronger.
I think it's important to remember that our business partnerships and our volunteers, actually our volunteers have put $3.4 million in in-kind donation of their time back in the schools. And so for others to step up, these are things that can't be replicated. So the whole issue of, do we have the best engineers in the world? The answer is yes, and they're right here.